Hello the internet and welcome back to Tony259, Tony359's second channel. Today on the bench I have the Apple IIc, which I have restored on the main channel, and today we are gonna restore the monitor which comes with this very Apple IIc. Now there are a couple of reasons why I have decided to move this video on the second channel. Number one is that CRT videos have never been popular, I'm not sure about that. Number two is that Apple videos have never been popular. Now, some Apple videos are better than others, but the restoration of this Apple IIc on my main channel has been doing pretty badly, and I didn't think that adding the monitor that comes with the Apple IIc was a good idea. So I decided just to move it on the second channel, and maybe I feel a bit more relaxed, and hopefully I can find a new audience that likes this kind of things. The other reason is that I don't think this is going to be like a particularly impressive video, because I understand that this monitor works. It needs a good TLC, replace the refa which is inside, and replace all the capacitors. And just to clarify, I'm not the replace all the capacitors guy, it's just the owner of this monitor would like this capacitor to be replaced. It's not a bad idea, it can't hurt unless you make a mistake, but I'm not the one that believes that you need to replace all the capacitors just for the sake of doing it. But in this case, we're gonna replace them all. Now, I'm not a massive fan of CRTs, they scare me, they're dangerous, but this one is very cute for a special reason. It's basically a 12 volts monitor. When you look inside, the first stage of the power supply, it's a 12 volts power supply, and the rest of the monitor is being driven with 12 volts. I have repaired two of these monitors on my main channel, so if you like this kind of things, go and take a look at those videos. And on one of them, I actually replaced the whole power supply section with a modern switching power supply, just generating 12 volts to power the rest of the monitor. So it's still a CRT, it's still kind of dangerous, but it's 12 volts, it feels a bit less willing to murder me, let's put it that way. The other peculiarity of this monitor is the stand. This comes with the original Apple stand. It's just a piece of metal, it's nothing special besides the attachment here at the bottom of the monitor, but it's impossible to find. So I've never seen it myself, I had only seen it online on some pictures, so it's kind of cute, it's nice to have a complete monitor, and the idea is that once you've done with your Apple IIc, you just push the Apple IIc inside this little cavity here, and everything is more tidy and more nice to see, I guess. So as I said, there's a refa inside this monitor, so we need to open it up, replace the refa, and then we can turn it on, make sure it works, and then we'll go ahead and replace all the capacitors and do all the adjustments. Let's get started. Alright, well, I think this is different from the monitors that I've serviced before. I don't remember this kind of layout, and also I don't think I see a refa capacitor in there. I think they're like modern type of noise suppression capacitors. These two grey-black things, probably you can't see that too much, but we'll get that in a minute. Yes, I remember it was a complete different thing. So we got the power supply here, that's the... I think that's where mains is coming, and yes, because obviously you got the switch in here, and then it goes to the transformer, which is outputting AC. AC is going to the motherboard is doing rectification, smoothing, and coming out with 12 volts that then powers on the rest of the monitor. So let me disassemble a bit more to just confirm there is no refa. At that point, I would say we can power it up and make sure it works before we start touching things. That's totally a different monitor, because the one that I've serviced, the board was accessible here at the back, while this one, it has a cage around, which I guess is good for interferences and all sort of stuff. But yeah, that's interesting that I wasn't aware there was two 240 volts models. Interesting. Little disclaimer, as usual with CRTs can be dangerous. The picture tube is like a big capacitor. It can store energy even when the plug is removed from mains, and they run at tens of thousands of volts. So if you don't know what you're doing around a CRT, just don't touch CRTs. Alright, this is a complete different model than the one I serviced before, and I cannot find anything online like schematics or anything. Anything is referring to the other model. So this is like something I have to explore from scratch. The first thing I see is that the other models, I think they were manufactured by Samsung. The CRT was a Samsung. I think the PCB said Samsung on it. This has a Hitachi picture tube and it's completely different. I would say it's a bit more advanced compared to the other one. I mean, not by a big deal, but anyways. So main is coming in here at the bottom left and it's being filtered by these two black capacitors. There are no refers inside this monitor, which is a good thing. And then mains is coming to this little board, back to the main switch through these yellow orange wires, back to the board, and then at the main transformer. The main transformer is completely different from the previous one. That's the one from an Apple 2C monitor. So you can see it's a complete different model. And the AC is coming back to this little board through these two red wires. Now this little board is actually the power supply board. We got the big board capacitor. We got some extra filtering, we got some, there's a couple of transistor, another one there. We got 4 diodes for rectification. We got the voltage adjusting trimmer. And then from this board, we have DC coming back to the main board. But while the Samsung monitor had 12 volts going back to the monitor, I think the Apple IIe monitor has 15 volts through a linear voltage regulator. So it's really, really simple design. This one has 3 wires going to the main board. One is the negative, is the ground, the chassis. The other 2, I don't know. So I'll be curious to see what kind of voltages this is working, because this is completely new for me. But the thing is, there are no refers. It looks like in decent shape. It smells a bit like old. And I think before I start poking and take a look at things, I'd like to put it back together and test it. Make sure it works. Then I would like to see what kind of voltages this is running on, just out of curiosity. And then we will have to remove the motherboard and, you know, I'll make a list of the capacitors, inspect everything, and we'll start working on it. All right, I've got this back together. Let me turn on the Apple IIc. Okay, Apple IIc started, so when we turn this on, we should have a picture. I got the switch turned to the on position, and this is being driven by my current limiter / isolation transformer, just for safety. And I guess we can turn it on and see whether we are getting a picture. In 3, 2, 1, go. Got the green light. Didn't hear high voltage, but it's a small monitor. Doesn't really do much. Do we get a picture? Yes. Okay. Yeah. It works. Well, thank you for watching. Well, it's nice that we know it works. There are no refers. It's nothing really fancy, but at least it tells us, you know, whether the picture is centered. And I would say it's in pretty good shape, to be honest. The next step would be, I'm just out of curiosity, I want to see what kind of voltages this is running on. So let me see if I can more or less safely take a reading of those 2 voltages. All right, this is the orange cable going to the motherboard. 3, 2, 1, go. And we got 10 volts. Okay, fair enough. So I'll take a note that the orange is 10 point some volts. And this is going to be the red wire. 3, 2, 1, go. It's the same, so I'm not sure I understand. It's the same polarity, 11. It's a bit more. Well, I don't know. Yeah, it's definitely, the other one was 10 point something. This is 11 point something. I don't know why this power supply is outputting 2 more or less identical voltages. Do they change? No, this is coming out of the power supply, so they won't change with brightness or anything. Anyways, we got 2 rails, more or less around, let's call it 12 volts. And that's it. Now, without service manual or anything, it's a little bit of a guesswork. Most importantly, I don't know what kind of voltage I would need to set on that trimmer. Is that going to be 10, 12, 11 point something? Without service manual, I can't guess it, and I don't really want to start assuming things, even though I suspect that this thing is not going to be like looking for a specific voltage. It's probably going to be in the ballpark of And sorry, I did set the camera so you could see the stable picture on the monitor. It decided to reset by itself. So sorry, I didn't notice it, but no, the monitor looks totally fine. So there you go. I would say the next step is to disassemble everything, and I would say probably make a list of capacitors, especially the big one on the power supply. I have a feeling I will have to place an order for that, and probably there will be a non-polarized one somewhere. Hoping it's not going to be an electrolytic, so we don't have to replace it. But let's take this apart, make a list of capacitors, and start servicing this thing. Ah! Oh, I hate that. And I thought the Samsung was complicated to open. I mean, this is unbelievable. It's unbelievably impossible to open. Unfortunately, I have to keep all these three parts linked together. So that's where mains is coming. As you can see, it's going to the filtering capacitors here. These are supposed to be refurbs, but they're not refurbs, thankfully. And then green, black, and gray are going to the power supply. From the power supply to the to the main switch, which is somewhere. Where did it go? Ah, it's still attached to the chassis. To the main switch, back to the power supply, to the transformer, and back to the power supply. And the power supply is then outputting DC through this cable here, which is the only one which has a connector. It's just, honestly, it's not the greatest. But anyways, you know, we got a few capacitors, not too many, so it should be okay. And we do have here a bipolar capacitor. It's a Nippon Chemicon. It's a 3.3 microfarad. I can't read the voltage, but it is definitely a bipolar, so I'll have to find a replacement for that, whether it's an electrolytic or something else. I will have to ask probably the Techknight. He's the guy when it comes to CRTs. I don't want to improvise on those things. But I don't see anything horrible here, like leaky capacitors, or at least obviously leaky capacitors or bulged capacitor. What I'm seeing here at the back is quite a lot of bodge work from the factory. We have 1, 2, 3 resistors, and I think it's a diode which are going across the board. Anyways, this is single layer board, so it should be fairly easy to just remove and replace those capacitors. Obviously, I'm sure that some will be in the way of this bodge work where they installed this horrible glue. Yeah, I can see one here. So well, I'll do my best. And yeah, so let me make sure that I have everything before I begin, particularly the bipolar capacitor. I remember having one I bought for probably for my own Apple IIe monitor, which is so much easier to open up, but it's bigger, so obviously that makes sense. We do have a few controls here. We have the vertical linearity, horizontal sub-hold, and down here we have the horizontal hold. And that's it. So this is where the power is going. This is the deflection. One is the vertical, one is the horizontal. I guess this is the horizontal. You can't see it. It says H. And I guess the other one is the vertical. And what else? That's the LED at the front. And this is the contrast trimmer or potentiometer. That's it. Let me make a list of everything and make sure I got everything before I begin. We also have, yes, obviously a couple of capacitors here, including this big one, which I hope I can find in this format. It's kind of a weird one. It's 25 volts, 4700 microfarad. Now this thing is like 40 years old. I'm hoping that I won't need to find something special like this, because obviously that was like a custom capacitor, I guess, back in the days. Hopefully nowadays this capacitor is so much smaller that this is not going to be a problem. But, we shall see. I'll make sure that I get something which is either the same size or smaller. You never know. That's it. I'll see you in a moment after I got all the components. I should now have all the capacitors for this recap, and when it came to the bipolar capacitor, I suddenly remembered one of Epictronics videos. If you don't know Epictronics channel, just go and take a look, the link is down below in the description, it's a very good channel. And I remember that he recapped very careful an Apple IIc monitor, and one of the capacitors, the bipolar one, exploded after like an hour of usage. And I thought, you know, what went wrong? What was wrong with that? I think he mentioned something about some frequencies, and then he ended up using a film capacitor instead. So I did a little bit of research, and it turns out that the original capacitor, which is this one, is rated for several amps of ripple, current ripple, while the modern capacitor of the same capacitance, which happens to be this one, and I know, this is 3.3 microfarad 50 volts, this is 3.3 microfarad 50 volts, they're both bipolar, but this is rated something like 40 milliamps of current ripple, while this is, I don't know, I haven't checked, but apparently it's supposed to be like several amps. So this will work from a capacitance standpoint and because of bipolar, but he will likely, now I can see now why, he will likely overheat and explode very soon. So after checking online, and thanks to everybody who helped me on Bad Caps forum in particular, someone explained me exactly what was wrong. The Techknight, my favorite Apple II person to go and ask question about, thank you Mike for your help, they all recommended this type of capacitor. This is a Panasonic film capacitor, 3.3 microfarad. I think this is 100 volts, so it's more than required. And to be honest, I mean, aesthetically, it will look totally fine because it's as wide as the original one. So there's not going to be a big deal to replace it. So that's the one that I code. And thank you everybody for pointing this out. Thank you Epictronics for showing that other video. Otherwise, probably this is would have gone up in smoke at some point. And while it's funny to see on camera, it's not funny anyways. So it's good that I caught up before, and hopefully we're not gonna have magic smoke. That being said, my own Apple IIe monitor, I recapped it several years ago, just for the sake of recapping it. I don't normally do that, but that one I went ahead and recapped it. And I'm confident I didn't use a film capacitor. I used an electrolytic one. But that's been running, I mean, I'm not really using it a huge amount, but it's still running. It hasn't exploded, as far as I know. So, at the end of the video, I'll take that out. We'll take a look at that capacitor to see in what kind of state it is. I don't remember this massive, disparity in dimension. Smaller, yes, but not so small. We'll take a look, and we'll take a look with the thermal camera, because my idea is that that capacitor is working, it's going up to stupid temperatures, and maybe it hasn't exploded yet. So that's gonna happen at the end of the video. We'll take it out and we'll take a look. But now, I guess I'll go ahead and swap all the capacitors, and I'll see you on the other side when hopefully everything is done and we are ready to try. Now, I'm not surprised that when it comes to CRTs, there are not many do-it-yourself PCB prototyping projects around the internet given the high voltages, though on the main channel I showed this ring tester, which I built myself with the sponsor of this video, PCBWay, and this is designed to test a flyback transformer from a CRT, and as you can see, this flyback transformer seems to be working totally fine. If you'd like to build your own ring tester or anything that requires a PCB, well then PCBWay is your stop. It is very simple, you just need what's called the Gerber file of the project of your choice, upload it on PCBWay.com, the system is more or less automatic, just choose a postal service and the PCBs will be delivered at your place. I've been using PCBWay for quite some time for my projects and I've never had an issue with the quality or the customer service, so I'm very happy to recommend PCBWay to you. And if your project requires 3D printing, metal sheet fabrication or CNC machining, well, PCBWay can help you with that. Take a look at PCBWay.com and explore all the services that PCBWay can offer you. Take a look at PCBWay.com, the link is also down below in the description, and let me thank PCBWay for sponsoring my videos, my channels. Their help makes these videos possible. So now let's go back on the Apple monitor. Capacitors are all replaced, and I've got this new tool from Zoe, which I'm probably going to show at some point on this channel. It's an LCR meter, and this time this actually works by using high-frequency pulses to measure the capacitor. So I understand it's reading ESR in an accurate way. It's not like my other cheap Atmel-based reader, which is still doing very good, but this is actually reading a pretty accurate ESR measurement, and it can read 100 hertz, 1 kilohertz, and 10 kilohertz. And my understanding, and I'm learning this from Defpom repair channel, link is down below in the description, thank you Scott for that, that when you're testing a capacitor, if you're testing it at 100 hertz, you get the highest ESR, and especially if the capacitor is like not too good, the ESR will be obviously wrong at 100 hertz rather than 10 kilohertz. 10 kilohertz it will raise a little bit, but 100 hertz it will raise quite a lot. So I've been testing capacitors, and to be honest, they are pretty good for their age, even though some of them have what looks like leakage at the bottom, but I think it's just the way the PCBs were manufactured but I think it's how PCBs were manufactured back then. You always had that kind of liquid on everywhere. I don't know if it's lacquer or flux or whatever. This is a 330 microfarad, and the reader is reading 310 and 588 milliohms, which is probably you can buy a better one these days, but 500 milliohms is totally fine. I have another 220 microfarad. It's reading 231 with 497 milliohms, so that looks fine as well. I got another one here. This is the 10 milliohms 100 volt that was inside by the flyback, so it was a bit toasty, and you'd expect this to have failed over time, particularly because it's an 85 degrees capacitor. It's not 105, and this is reading 8.8 and only 2.1 ohms. This is only 10 microfarads, so the lowest the capacitance, the higher the expected ESR. That is totally fine. The only one which I feel might have been a bit bad is these 2.2 microfarad 250 volts. It was placed here close to the flyback, of course, and these at 100 hertz is reading 38 as ESR, which is definitely a bit too high. That being said, the replacement one, which is Panasonic NHG, you can't get the low ESR at 2.2 microfarad. I think it's just the way they're manufactured. But this is reading 12 ohms, so it's still pretty high. And again, for 2.2 microfarad, it's, I would say, it's totally expected. This is reading 12, and this is reading 38. So there is definitely probably reason to replace this one. That being said, if I change the tool to 10 kilohertz, then the, let's call it back capacitor, is now reading 4.6 ohms, which is still on the high side. But if I'm reading the new one, the brand new one, is reading 5.9, which is even higher. So I'm not entirely sure, but the bottom line is these capacitors seem to be, I don't want to say totally fine, but probably totally working, probably for many more years. So capacitors are all replaced, and I think I'm going to go ahead and just test the power supply section by itself first. It probably is not going to output those, I think it was like 10 point some volts that we were reading before because there's no load, but I want to give it a go, before I power this thing, and, just to be on the safe side. So let me reassemble this and put it in a kind of safe way. There's nothing safe on this desk at the moment, but, let me try this and we'll test the power supply section by itself. Alright, I got the Fluke and the Kaiwitz connected to the two rails. I believe they are more or less the same. One probably is more regulated than the other. I'm not entirely sure, but I think they read something like 10 point some volts. And the rest of the PCB is not connected, so this is just the power supply section. I'm not expecting super precise values because there's no load. I just want to make sure that everything works. So let's give it a go. 3, 2, 1, go. Yeah, we got 14 and 15 with no load. They are pretty similar as they were before, and everything seems to be fine. No smoke, no nothing, so that's great. So let's plug everything back. I guess the CRT will have to go back as well for a test, and let's hope that I didn't make any mistakes. Alright, it's taken absolutely forever to put that back together. It's like a big origami, and it's so much more complicated and complex to put together than my other Apple II monitor made by Samsung. I'm really hoping that nothing goes wrong, because not only it would be difficult to diagnose because everything is small and everything, but it also is going to take an age to just disassemble it together, and I'm not sure I can test it while it's open. So no, I've been procrastinating this project for quite some time now, and I'm not ashamed to admit that this is because I'm concerned that something goes wrong. I don't know, it's just my way sometimes of dealing with things. So hopefully, finger crossed, it's gonna work, because if it doesn't, I don't know what to do. There are parts inside this monitor which are like millimeters away from shorting everything. So I don't know, I'll have to give it a go and see what happens, otherwise I'm not moving forward. I've got the Apple IIc connected to this monitor. Let's turn it on. Now it's time to turn it on. Will it work? Let's find out. In 3, 2, 1, go. Heard something. Ooh, we got something. Ooh. It's, yeah, okay, the vertical hold is not correct, but it's on. There's no smoke coming out of it. I can breathe, hopefully. We're still in time for some smoke. But yeah, that's such a relief. You have no idea how. Oh. Ah, that's better. Okay, well, this is such a relief. It's amazing. It works and it looks fine. I don't see anything wrong with it. Now, obviously, adjusting things on this monitor is going to be mostly impossible. I'll take a look. But again, everything is absolutely unreachable, and disassembling this thing is just not an option. It's just something I'm not sure I want to do at this time, because there's so many things that can go wrong, so many cables which are just there ready to rip some components off or touch things that they're not supposed to. So I'm super happy that this is working. I'll take a look, obviously, see if there's anything major to be done to the geometry, and then I guess it's time to give it a clean and put it back together. Right, it's taken quite some time. I really don't like this design. The Samsung is so much more serviceable, let's put it that way. Still very crammed in, but if I remember right, it's much easier to access all those controls. I ended up having to remove the power supply section and operate the monitor with the power supply section hanging, as you can see now, which, you know, it makes things even more uncomfortable. But in the end, I think I ended up with a decent result. Ideally, I think you'd like the picture to be a bit lower, like a few millimeters lower. I think it's so much better than it was before. It was almost touching the bezel, the top of the bezel here. But I tried quite some time, and again, every time I'm doing an adjustment, I'm doing it with the monitor turned off. I don't feel brave enough to stick my hands in there. Not because the hand, I could use some gloves. It's just because the whole CRT is not stable. Until you have the case on top, everything can touch anything. So my concern is not me getting electrocuted, it's frying the PCB, because there is a possibility that while I'm adjusting those rings, I'm actually causing a short somewhere. So I think this is totally fine, it works totally well, and again, it's just mildly off, which is, to be honest, for these old monitors, it's pretty normal. But yeah, I think I'm happy with that. What do you think about it? Comment down below as usual. What matters is that I've been power cycling this monitor so many times and everything seems to be working totally fine. All the adjustments at the back are correct. On the PCB we have some sub adjustments for brightness, for vertical hold, for I think that's another one, but it doesn't really need those adjustments because I can totally adjust everything from the back. There's no need to adjust those things, and the focus is always very good. It looks like, I think it's in good, this monitor is in good shape. I don't see any burning. And the brightness is reasonable. These monitors are pretty dim, if I remember right. At least the Samsung, I remember when I worked on the last one, it was pretty dim. So I think it's high time to just put this back together, give it a good clean, put it back together, close it, and finish this video finally.
VESA mount adapter will be $199 and the Pro stand $999.
Oh, l'aeroplano, ma è possibile? Before I'm wrapping up this video, I'd like to take a look at my Apple IIe monitor. This is a monochrome monitor. It's a bit bigger than the 2C. It's definitely much spacious inside, and I got this monitor way before this channel was born. I got it, I've retrobrighted it badly because I can see marbling effect in here, and I recapped it completely. Now, after what we learned about that capacitor, the bipolar capacitor, I'm concerned I might have a struggling bipolar capacitor in this monitor because I cannot possibly remember what I used to replace it. I thought that any bipolar capacitor would work, and my concern is that I might have selected like a 105 degrees capacitors as I usually do, and this is kind of coping with the task, but probably not too much. So let's open it up, let's check with the thermal camera what that bipolar capacitor is doing, and if it's getting hot, maybe I can get another one and just bring this monitor, you know, up to spec, up to task. A little curiosity on this monitor. When I got it, I opened it up before turning it on to just take a look, and this monitor has 4 reefers, and I believe like 2 or 3 were exploded, so someone had turned it on at some point and saw the smoke coming out of the monitor, but the monitor can work without the reefers, it's totally fine. I'd be curious, you know, to see the face when they see smoke coming out of the monitor, but the monitor is still working, I don't know. But yeah, I went ahead, obviously replaced all the reefers, and the monitor was working totally fine, and then I went ahead and just recapped it for the sake of doing it. We are inside the monitor, and this is the bipolar capacitor. Now, this is much bigger than the one I found for the 2C. Obviously, it's a different value. The one for the 2C, I think it was the only one available on either Mouser or DigiKey. This one, I bought it in 2020 from eBay. I found the email, and I had to check on the email because from the capacitor I can't figure out what the series of the capacitor is, and it turns out to be the UDB series from Nichicon. It's rated 85 degrees. I think that was the only option available. There was no 105, and this is rated 660 milliamps at 1.3 kilohertz. Now, is that gonna be enough for this kind of task? I don't know. As a comparison, the capacitor I found for the 2C, which was a different value, 3.3 microfarad at 50 ohms, was only rated 22 milliamps. So this is 660. Probably this is up to spec. I'm assuming that probably over time those bipolar capacitors have disappeared from the Mouser catalog, because if I'm not mistaken, when I selected that capacitor for the Apple IIc, that was the only one available, unless it was the only one available at 105 degrees. I didn't really know about the current ripple, so maybe I just got the wrong one unintentionally. Now, what I'd like to do is to power up this monitor, let it run for a while, and then with the thermal camera we can check whether that capacitor is getting hot at all or whether it's doing totally fine. So the monitor is running. I'll let it run for a little while, and then we'll take a look with the thermal camera. The monitor's been running for about 45 minutes, and I can see that capacitor, it's running at around 44-45 degrees, which is kind of on the high side. I believe that's only an 85 degrees rated capacitor, but it's totally fine. I guess, indeed, there's probably quite a lot of current flowing through it, and that's why it's getting warm, but it looks like that capacitor is nowhere near the rated maximum, so, you know, that's not going to be a problem for this monitor. For next time, probably those capacitors I use for the 2C monitor is going to be a better choice. But I'm super glad this monitor is okay and it's so much easier to work on this monitor. There's so much space, the PCB, it's so much bigger and everything is so easy to just replace and probe whatever happens. So yeah, that was so much easier, definitely so much easier than the Apple IIc monitor, the Hitachi version in particular. So I guess this is it for this video. I will definitely go ahead and test that IIc monitor for a few hours, to make sure that everything is working totally fine before sending it back to its owner. And I hope that monitor is gonna last for many, many years to come with its very nice Apple IIc. Everything looks so nice and clean. And the Apple IIc, if you haven't watched the video, it's on my main channel, and it was a pretty nice repair. It turned out to be absolutely amazing. And this Apple IIc has the Alps keyboard, which feels absolutely fantastic. Let's take a look at that video if you haven't watched it. I hope you enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my main channel if you like this kind of things. I'm on Patreon if you would like to support me. The name of my supporters on Patreon is scrolling somewhere here on the screen. Thank you very much for your support. You're absolutely amazing. There is a free tier on my Patreon account, so there is no excuse. But if you don't want to support me on Patreon, which is very much understandable, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, that's also totally fine. Your visit here, maybe a thumb up, a comment, a subscription. If you really could, that would be absolutely fantastic. That's it for today. I wish you a great day and hope to see you again soon here on my channels for my next videos. Thank you very much and goodbye. Bye-bye.